To Power Electronics lecture series. Here in this session I'll be going to discuss about triac, and these are my session outlines, where first I'll explain what is the meaning of triac, then we'll see some uses of triac, then we'll observe symbol of triac, then I'll explain triac equivalent circuit, then we'll see characteristic of triac, and at the end we'll conclude this session with applications of triac. So let us begin this session with first point, that is meaning of triac. So triac means triode for alternating current. Triac means triode for alternating current. So TRI, that is there in triac, like this, and then this A, and then this C. So ultimately triode for alternating current. So it is a triode for alternating current, means it is advanced version of diode, which is what triode. And in diode, as we know, once it is in forward bias it will get conducted, but in triode, by having a controlled signal, we can have a conduction in forward bias. So that is what difference in between diode and triode. Triode is having a controlling third terminal, and diode does not have any controlling third terminal. But triac means triode for alternating current. You will come to know like what is that exact meaning after having this session. So this is what the basic full form of this. And then what is the use of triac? So unlike SCR, we can trigger this in both of the direction. In SCR, we have facility to trigger SCR in forward bias only, but triac can trigger in both of the direction. So unlike SCR, triac can trigger in both direction. Unlike SCR, triac can trigger in both direction. Now let us have a symbol of triac. So symbol of triac is, it is 3-terminal device. This is MT1, let us say this is MT2, and third terminal this is gate. So this triac is 3-terminal device, and it is bidirectional device. So triac could be even considered as two back-to-back SCRs are connected. So triac is 3-terminal device, MT1, MT2 and gate. Let us try to understand this triac by its equivalent circuit. So if I say this is what triac which I have right now, so this is MT1, this is MT2 and this is gate terminal. Now equivalent circuit of this, that is explaining SCRs are connected, two back-to-back SCRs are connected. So ultimately one can clearly understand that like this is MT1 and two back-to-back SCR means one SCR is connected like this and other SCR this is MT2, and gate of both of the SCR are connected. So its equivalent circuit is two back-to-back SCR, and a gate of both of the SCR is combined together. So ultimately when we talk about its operation, if MT1 is positive with respect to MT2, then this SCR, let us say this is T1, So T1 SCR, that is getting triggered in forward bias, and T2, that is in reverse bias, and MT2 is positive with respect to MT1. At that time T2 is in forward bias and T1 is in reverse bias. So in both of the cases there will be a characteristic of SCR provided gate control is there. So when we see its characteristic, like if MT1 is positive with respect to MT2, so at that time this T1 is in forward bias and T2 is in reverse bias. So one can clearly say its characteristic is like this. And here we have gate control even. So as we increase gate current, triggering will get earlier. And if I say this is for IG1, this is for IG2, and this is for IG3, then here IG3 is greater than IG2 is greater than IG1. It means as gate current increases, forward voltage decreases. So this is how characteristic is there when MT1 is positive with respect to MT2. Now when we talk about MT2 is positive with respect to MT1, so at that time we'll be having T2 SCR in forward bias and T1 SCR in reverse bias. So during that time period one can clearly see T2 will be in forward bias and T1 will be in reverse bias. So its characteristic is similar to forward bias SCR characteristic, which will be the characteristic of T2, and once it get triggered its current will be like this. And here even there will be two cases, three cases are possible, like as you increase gate current, forward breakover voltage will decrease. So this is what I am observing, like as if I increase gate current, as we have seen it for MT1 is positive with respect to MT2. Let us say this is for IG1 is for IG2 and this is for IG3. So here IG3 is greater than IG2 is greater than IG1, where forward breakover voltage decreases as gate current increases, and that is what the case which we have it for MT2 is positive with respect to MT1. So that is how we have triac and that is bidirectional device and it has controlled in both of the direction. So this is how it differs from SCR. When we talk about diac, it is even bidirectional device but there is no gate control. But when we talk about triac, it is a bidirectional device with gate control. So there are so many applications which is there regarding triac. Let us discuss few. It could be utilized in lamp control. We use that in speed control of fans. It could be utilized in chopper and in AC phase control. We can use it. So that many applications are there regarding triac. Thank you so much for watching this video. If you have any question regarding this topic, then place your questions in comments so that we can have a discussion. And you can go through my website engineeringfunda.tk, where you will be finding different courses regarding engineering, which is what I am explaining it to have a betterment of engineering understanding. So ultimately just go through the entire course, which is what I'm giving it right now. And if you have any query, then write that in comment and suggest few videos if it is required to have a better understanding of engineering subjects. Thank you so much for watching this video.